Hello, everybody. Yesterday, the 28th August 2020, we had in Star Citizen a nice calling all deaths with the topics about Cortec. For me, it was a quite interesting calling all deaths, but for some people, I think it was a kind of what the hell are they talking about? So I decided, as maybe others did, hey, let's try to make a calling all deaths Cortec for dummies. Don't be offended, I just want to try to explain it in a way which is more focused on real world. So the warning one, I try to explain it in a real world example, and this will not fit perfectly, but it will give you a grasp feeling about the topic, about how it's done, how it's work, why it should work that way. So the second warning also is I made it in PowerPoint, so don't be surprised. It's a simple PowerPoint with no big animation, with no high styled designs. It's just working as intended. So bear with me. And now let's get starting. Starting is important that I give you some pre-assumptions you have to take care and bear with me. So one is the server. We have the server, as you see, the big square, and the server can currently hold 50 users. Then we have the in-memory storage, which is just this kind of square, the inner one, and then we have this kind of desk where is representing the client we are using, and then here the guys we are, which always want to have some cookies, some ships, some teddy bears, some penguins, whatever. So that's the server. Currently, we have a server. We have an in-memory database. That means it's the database. It's in the server. Not completely, but just wait some seconds. Now, how can you that imagine with a real-world example? A real-world example would be kind of your local renting library. You know, in your town, you maybe have a library where you can go there and rent some books. That's the kind of way you can thinking about your data. The ship loadout, the money you have, the storage you're currently transporting. That's kind of books, and you're renting them. And some books are available, and some are not because yeah, it's a library which have a limitation on space. It can't hold any data. It have to decide which kind of data are important enough. So that sometimes you go to the library and ask for a book and they can organize it for you, but it will take time. So what does it mean? That's the next step. The global persistent. So sorry. The global persistent means it's the database. It's all data stored. And you can imagine that was the image was already shown shortly as the big place where all books are stored. All the data, all users, all just everything. And that needs space. And the local library don't have that space. So you can also imagine, and that's the second part, this API which is written there, you can imagine it have somehow to the books from the big storage have to go to the local library. And that's where the ramps comes, the transportation, the logistic. So you can imagine the API are kind of ramps. So they're defining what kind of transportation is allowed on what ramp and what will be moved in this ramp. So, for example, you can say on this ramp only data from ships are allowed, and therefore it needs this and this size of the transportation. Just as a kind of try to give you an image of this. So we have the database global persistent, which is a big library with all books containing, and then we need some API, some ramps, so that the people with the transportations can go there and get the books, so the books can be going to your local library. That's the real life example I try to explain now. So on the left we have our local storage, our local library or the server. On the right we have the global persistence, the database, which is currently mostly only holding the user data. Just one step after another. So you have to imagine now, if the data is available, if you already called your ship, it's in the memory. So the next time you call the ship, it's quite fast. But the first time, the server have to call to the global persistence or the database and say, guys, I need this ship with the loadout, with the damage it already have, with the fuel it already have, and so on and so on. That means somehow the data have to be transported back to you. So what it looks like quite a long way, in reality it's maybe 5-10 seconds. It sounds a lot or less, it's depending. I mean, if you're waiting 10 seconds, it feels always longer than if you just getting it. One trick they're currently doing is with this, your current ship will be retrieved, please wait. This already takes some seconds, and so you will not get this feeling like this truck needs a whole long way to get your data to the server. So yeah, that's how it's done. And now we have the iCache. The iCache, this small little thing, you can imagine like a hub from logistic perspective. So for example, you can say, okay, we have these 5 town libraries, and we now make a location where we store some of the books they always requesting or more often requesting, and we store them here. So what does it mean? It means, again, on this perspective, we have the big library, the big storage, and the big trucks, and these big trucks just driving to this hub. Maybe don't have to drive in a city, don't have the traffic which is in a city usually. So the truck can get quite fast to this hub or this iCache. The data get faster to a hub. And then on the other side, we can use smaller units or faster ways to transport the data needed. So we don't need any more a truck. So this smaller car will get faster through the traffic in the town and will not have an issue if there is some construction running, and so on and so on. That's the way you can imagine the whole flow. That's the main idea of the iCache. The iCache means we get some data they usually want, and we try to take care of the data in a closer way. And now the question is, okay guys, it's nice we're talking about, but what's the benefit? The benefit is scaling. Scaling means we can starting to make server meshing, what you already see here in below. And what's more important, we can start handling the data better. So we still have some data which are important, which are on the server. So for example, in Port Olisar, Lorwell doesn't need to know that there are 5 rockets currently targeting you and try to hit you, because you're in Port Olisar. So Lorwell, New Baggage, they don't need to know it. So it's in the local library store, this information that currently you try to evade 5 rockets. But it's important for Lorwell or New Baggage to know that somebody else attacked you. So this information that this guy attacked you and will now have a crime stat will be stored on the iCache, and all of the system will now know that this guy is a bad guy because he attacked you, because you was a nice guy and you didn't have a crime stat, and he just decided to pull some rockets at you. So that's the way how it would work. So we have data on the region base, and we have data which all need to know. And now again, you can say, okay, why we don't put it there in the global persistent? Simple. It takes time. I mean, you have to imagine again. So we have again this big truck who have to drive to your town library, have to go through the traffic, and this big truck will have some issues. So it's better if we have a small way and they send it there on this iCache, on this hub, and then from there the big transportation will go to the database. So now the question is for sure, okay, how can this work? I can now give an example of another game like Dark Age of Camelot. Dark Age of Camelot was an MMORPG which also had used in-memory database. So if you as soon you logged in, your character was loaded in the memory, and every 10 minutes it was saved on the database. So and back then when this was developed and this was designed, space and also the CPU was limited. We had to take care quite a lot more with resources. Now we have 84 cores, 128 cores, and name it. We have a lot of possibilities wasting resources, you can say. And yeah, so what does it mean what I try to explain? So you can imagine the information of the crime stat, for example. It's an information which is important and all need to know, because the guy maybe who already destroyed you in the meantime traveling to New Babbage, and everybody should know that he is a bad guy. So it's need to be in the iCache. And for sure, if he log out or everything, it needs to be known as soon he logged in back. So this iCache will work as a kind of important real-time data, and it will take care of frequently saving the data in the global persistent. So yes, it's let's say the damage of your ship. It's a good other example. It's important to know that your ship is to have 20% damage on this thruster. It's an important information currently. And it's an important information if you log out and log in. But it's not something important that it have to be saved immediately in the global persistent. So that's what they also now try to accomplish. That's what also is a bit troublesome. They have to decide which information need in which frequency transported from the iCache to the global persistence, to the database. That's what they have to take care of. And that's also what the part of this API means. They have to make the RAMs, they have to decide, okay, we have 5 RAMs for crime stat information, but we need 10, or we need or we have we don't have enough ramps for transportation of trading information. And it's now a simple explained example, but it's how you can imagine it. It's this kind of optimization they need to make. They have to decide what data is in which frequency important, what data have to be saved in which frequency, and what data have to be stored. So for example, if you log in on Stanton system, they already know, okay, you logging into Stanton, so I have to ask the global persistent, give me all data of you and put it there in the iCache of Stanton. If you're traveling to Pyro, I have to inform the Pyro iCache will ask the global persistence. In the meantime, the Stanton iCache have to send to the global persistent the new data, that you have 20% damage on the thruster, that you have only 5% fuel left. That's what it have to write in the global persistent, and the iCache of Pyro needs to know. And you can go now a step further. You can go and say, okay, the iCache don't have to be system specific. Some systems maybe are that small that you can put several systems on one iCache, and some systems are that big that, for example, you have an iCache just for Port Olisar and Lorville, for example. can be happen. And this is the part which have to work. This defining of data responsibility and priority. So that's already a part of server meshing, why iCache and global persistence are important. Without that, we can start discussing with server meshing, because server meshing requires that the data are somewhere globally stored. And again, now you can go back to this example with the library. Now we have this global persistent. That means we can save that this cup of tea is on this desk, because it's an information we can put in the iCache, and because nobody interacts with this cup, it goes to the global persistent. And it as soon somebody go to Port Olisar, he will have in the iCache the information that on this desk is a cup of tea, and he takes it now. If you don't interact with it, it's still in the iCache, and then again back in the global persistent. And that's also a part of the topic. Only changes will then communicating. That's also an important task, reducing the amount which the transportation have to transport. So with the iCache, and that's also the part of the query optimization they mentioned, it's what should be put in the transporter. So if you are in Port Olisar, you only need the information of Port Olisar from the iCache. All the other information are currently not necessary. Maybe there's some information declared as Stanton information, like the crime stat, and then you will also receive this. But in most cases, you only receive the information you need. That's again this query optimization. And that means less data to transport it. Less data means faster data going to you. I hope it's quite feasible to understand. So now we covered iCache, global persistence, and server meshing. The final step, it's after all this talk, it's a bit silly, but it have to be taken care of. What currently the networking team doing? The networking team, you have to imagine now, we will have sooner or later this iCache, and we will sooner or later have the server meshing. And simple said, timing means just nothing else than the information that you're traveling from Port Olisar to Lorville have to be in sync. And it have to be on sync for you, but more importantly, it have to be in sync for all others. And this is what they talk about, rubber banding, about lags. This is what happens. I mean, you can imagine this package in this image is the data you're holding. And currently, a lot of data have to be transported, a lot of information, unnecessary information have to be transported. So they already tried to reduce it with object container systems, but it's not yet there. And they can really fine tuning it only after iCaching existing. So what they're currently doing is to understand the timing issues they have, and for sure the time sync, because it's important that both server running on the same time. Now you think, what the hell are you talking about? I mean, same time, it's clear, it's logical. Yeah, on one side true, but somewhere somebody have to decide which time is it, and then all have to accept this timing. So I can go back to my experience as software developer in a example of time stamping. So people go to work, have to go to a terminal, have to put their user card, and then the time was tracked. That they now starting at this station the work, and at this time they stop the work, so that means they worked on this project, on this production, this amount of minutes. And it sounds easy. I mean, we are talking about a server, the server will have time sync. It sounds easy, but we had several second time difference. Now on time tracking, some seconds are, you can handle it. We didn't, but you can. On gaming, forget it. On gaming, every millisecond matters. And that's what they currently try to find a solution. And that's what's currently not working. I mean, as you imagine, we have some issues. You're starting the rocket, and as soon the rockets go there, you see how the rocket move forward and backward, and this is the syncing problem. The client and the server can't agree on on the same timing. And this means some information will get faster to you, some information slower, and the client and the server can't decide which information was on which time sent. And this delay causing these issues of rubber banding, so the rocket which strangely driving, or the ship strangely moving, and also the whole lag, the input lag, the reaction lag. And for the network team, it means most likely they have to think about how this package is done. They have to think about how to optimize the package, make it smaller or make it more handy, or yeah, that's the whole topic about. And so I'm going back here. I think I covered now everything up about this calling all devs. I hope with this library and bookstore example, I was able to give you a kind of feeling what's the issue, how it have to be handled. I mean, that's also kind of real life example. If a new book from a new author is released, and in this region the author is famous, this is again iCache. iCache should know, oh, currently this new data is there, and everybody wants this data, so it's better to have this data on the iCache and not holding it back in the global persistent. And this is all what's make it more tricky. Handling the data, deciding the data, and this is what also troublesome, and I understand it, and it's nice that now explained it a bit further and confirmed some of my thinking, because as long they don't talk about it, I just can think about as a developer, how would I do it? And now they confirmed it in some parts what they're doing, and so I was now able to give you some insight in a for dummies way. I hope that was good enough for you. Thanks for your time, and see you next time. Bye.